start? Yeah. Okay. All right. Welcome back. I'm not sure if this coffee break was too long or too short, but I hope it did good for everybody. And we're ready for the next three or the last three presentations. Um, I've mentioned a couple of times now that we are focusing on environmental aspects of EOR, and that there is interest for that also in Brazil. And regarding environmental aspects, we have environmental risk tools developed in Norway that we also can use for the purpose of EOR. So I just wanted us to have a look into the risk assessment tools that we use in Norway. And my colleague Emily Ling is using this tool as a research-based service for oil companies, Norway and abroad. Vær så god, Emily.
Is this one on? Can you hear me? Yep. Okay, so as Steiner said, I'm working together with him in NORS. I work as a researcher in the Marine and Ecology Group. I used to be the Marine Environment Group, and now in NORS we are the Marine Ecology Group. And we're both based at the Meshevik Marine Research Center. So I'm going to talk a little bit about environmental risk assessment and the methodology that we're using for produced water discharges on the Norwegian continental shelf. So first, a definition of environmental risk. It's basically any actual or potential threat of adverse effects for living organisms. And this can come from any of an organization's activities, effluents, emissions, wastes, and resource depletion. And I will talk about DREAM. This is SINTEF's model. It's the dose-related risk and effects assessment model. So it was first developed in a joint industry project. The original research institutes involved were SINTEF, who licenses the software, ourselves, that was then Rogaland's Forskning Aquamiljø, that then became IRIS and is now NORS, and TNO in the Netherlands, and of course all the oil industry partners. It's basically developed as a tool to guide management decisions in order to reduce your environmental impact. So it's not something that's actually changing your environmental impact. It's a way of measuring it and comparing it between different discharges. It basically works as a fate simulation of the discharge, and then you have a calculation of something called the environmental impact factor. And they have developed it for both produced water and drilling discharges. So I'm going to talk a little bit about DREAM. I'll mention briefly the biomarker bridge concept, which was developed in NORS, and then I will talk a little bit about the implications or applications within EOR, which I have a slightly more understanding of now after listening to some of the presentations earlier. So first of all, I want to mention the OSPAR recommendations, which came into effect for produced water discharge assessment. And it's a risk-based assessment. And you can use DREAM for steps 2 and 4 here. So the hazard assessment and the exposure assessment are both taken care of in the DREAM model. And then you have the risk characterization, which is essentially your EIF, the impact factor. What the oil companies can then do with the number is use it towards risk management. They can look at risk reduction, whether it's chemical substitution or implementation of BAT-BEP. And you can follow it up with monitoring. So you always have a feedback loop with environmental risk assessment, from data collection to risk management and monitoring, and it feeds back on itself. So this image, I believe, was created by Mark Reed in SINTEF during the original project, and it just gives an overview of what the model is simulating. So you have the physical chemical fate of your components for all kinds of regular or irregular discharges. So you have the discharges released, your oil droplets are rising to the surface, where you have, of course, evaporation. You have degradation in the water column. You have adsorption and desorption to particles, and you have sedimentation. And then particularly if you're looking at drilling simulations, then you also have deposition, resuspension, and degradation in the sediment layer. And all of these are taken into account in the fate of the chemicals in the DREAM model. This is just general information on the input. Probably the most important things to remember is the PNEC, which is the predicted no effect concentration. The produced water rate is also very important when it comes to your calculation of your impact factor. And in terms of EOR, then you also have the biodegradation, I think, is probably going to be an important factor as well, particularly maybe with polymers. So the model is based on something called an SSD, which is a species sensitivity distribution. And this is basically just statistical distribution, and it plots the cumulative sensitivity of species against the concentration of the toxicant in the environment. And this is where you derive the PNEC. So the PNEC is the level where in risk assessment we usually have it set at 5%. So this means you protect 95% of the species. And if you divide the species sensitivity distribution curve by the PNEC, it shifts the curve. It's purely mathematical, but it will shift the curve so that this 5% level is where PEC-PNEC ratio is equal to 1. PEC is your predicted environmental concentration. So that's what concentration of everything you have in the water column, and the PNEC, again, is the one where you have no observable effects. So the aim is to protect 95% of the species. So DREAM is calculating the fate and the concentration of all your components, the natural components and the chemicals are all included. And this is your PEC. And for every single component in your release, it then compares this to the PNEC using the SSD. And anywhere where PEC-PNEC is over, PEC-PNEC ratio is over 1, that is the area where your risk is over 5%, which is the threshold. And an EIF of 1 is a cube of 100 by 100 by 10 meters. So you get a volume of water where you have potential risk to the environment above this sort of symbolic threshold of 5%. What you can get out of the model then is the PEC. So it predicts the fate first. So you have your environmental concentration in the water column and your risk. So you can see the distance from your site that you're affecting potentially the environment. And the piece that is very useful for the oil companies is that you also get the contribution to risk. So they can look at their risk and then they can say, okay, chemical 2 here is dominating the risk. So if we can find a way to reduce this chemical or to either by substitution or just plain reduction, sometimes you're using more than you need to just to be sure. Anything that you can reduce on chemical 2 will reduce your risk to the environment. So ever since the OSPAR recommendations, the EIF calculation for produced water is now mandatory in Norway. So if you're doing anything for improved oil recovery, which will affect the content or the volume of the produced water, at some point down the line, it's going to end up in an EIF calculation. We also have the possibility to run whole effluent toxicity because you have a lot of interactions with the chemicals down the well, which are not taken account of in the actual model. So part of the OSPAR recommendations was whole effluent toxicity. So then you assess the toxicity of what comes out as a whole effluent rather than on a component-based level. Sometimes it comes out more toxic than the individual components, and other times it comes out less toxic because of the way they all react together. And I won't talk about the drilling discharge, I don't think, but this is also developed for the Norwegian continental shelf, and there you have the toxicity of the chemicals, but you also have burial of organisms and the change in your sediment structure and oxygen depletion. All of these pose an environmental risk. So yeah, following your dream simulation, you then have the application of BEP-BAP policies. These can all mitigate the risk. And as I mentioned earlier, you can have chemical substitution, re-injection, cleaning technologies. So if you have a technology for IOR that is increasing the risk in some level, you can also think alongside of it, well, how can we clean this afterwards before it is released? Yeah, we also are involved in monitoring. So NORSA has been involved in the water column monitoring program for many years in Norway, working together with NIVA. Where you have mussels and fish exposed in cages offshore. So you can feed back the whole risk assessment to actual monitoring and see if your actual predicted risk is the same as what you're measuring in the field with the biological organisms. The biomarker bridge distribution and the biomarker response distribution. It's basically exactly the same thing as your species sensitivity distribution, except you're using biomarker responses. And these are the things that change in organisms when they are exposed to chemicals. So you have things like oxidative stress, and you have biomarkers, chemical analyses. You have all of these can be measured in a lab setting, and you can plot this cumulative sensitivity to different biomarker responses in the same way as whole organism species sensitivity. And that gives you what we call a biomarker response distribution instead of a species sensitivity distribution. And if you plot this against the risk curve, you get the biomarker bridge. These ones you can put into Dream. This is some very complicated curves that me and Steiner and others have been working on and looking at for a long time. We have hundreds of these curves for all kinds of different biomarkers. And you can incorporate these into Dream to visualize the risk of effects in organisms based on your predicted environmental concentration. So then instead of getting a risk picture, which is the risk to all species in general, you can look at the suborganism level responses. So you can plot the percentage of species that are likely to be having some kind of biomarker response in, for example, lysosomal membrane stability, which is a general stress biomarker. And then I left a little bit of time at the end to talk about the applications for IOR methods and things to think about when you're developing your IOR methods. Basically, anything that changes your produced water is going to change the EIF some way, one way or another. Anything that involves reinjection generally leads to a greatly reduced EIF because you're not releasing the produced water. So the chemicals that would normally be going out are instead going back into the well. So you can get, I have one site where they have 97% reinjection, I think. They have a very tiny EIF value. Chemicals, for example, the tracers that were being talked about. If you have low toxicity, that's great. If you have low concentration, that's great. So this one where it changed from barrels to vials, this is a positive thing. It will reduce the risk, and they will be included in the EIF when you're using them because you have to. So yeah, the smaller amount you can use, the better. Polymers, I don't know a lot about polymers. I know they're quite tricky because you have a low toxicity. So generally you would get no EIF from polymers, but at the same time they're not allowed because they don't biodegrade in Norway. So you have then biodegradable polymers. Maybe they can be included as biodegraded components because that's going to have a different risk factor than the polymer itself. But the other thing that was mentioned at the end of one of the previous talks, if you need to include biocides, they very often have a very low toxicity because they're basically designed to kill biology. So they're quite toxic. So when you have biocides, your EIF tends to go pshung. Yeah, so I'm sure there are many other things that you guys can all think of that you're doing that may or may not affect the produced water. Of course, the DREAM model is not going to cover every aspect of environmental assessment for IOR because there are some things that don't have anything to do with produced water, and there are some things that do. I just wanted to mention the IOR Center. There will be a PhD student. The environment is a theme across all of the IOR methods at the center, the environmental assessment. So there will be a PhD student working on environmental risk assessment for IOR methods there. Other than that, I'm happy to take any questions, I think. I don't know how I did on time.
Yeah. Thank you, Emily. That was a very concise and brief introduction to how we do environmental risk assessment and how it can be applied to EOR assessments. Are there any questions at this point? Yeah, okay. If not, then thank you. And then we go on to the next speaker, and that will be kind of like a stage shift in a way when it comes to topics. Now we will have, oh, what's your name? Clesio Rock de Boom. Okay. Who is from this institute, and he wants to give a talk on image processing, artificial intelligence, classifications, and simulations of rock properties in multiscale. So when we have that ready, then please.
Oi? Aqui passa também. Pronto. Everybody can hear me? I guess so. Well, I'm Clécio Debon. I'm an assistant professor in a small university here in Rio de Janeiro. I'm also a physicist, and I'm going to talk you about image processing, artificial intelligence, and applications we do here at CBPF um, in petrophysics. I'll mostly talk about exploration. Well, actually, I'm not talking alone. I'm talking on behalf of this great team that is here today watching us, the CBPF team, uh, led by these five people here, and also the other team members who has been working with us for a couple of years. Just to give an idea on how much people are involved in these efforts. Well, we most the research areas we do here, we work in several research fields, from scientific instrumentation by building a microscope tuned for petrophysics, artificial intelligence. There are two teams working on that right now. Image and signal processing, which usually comes with artificial intelligence. High performance computing, because this wouldn't be possible without GPUs and parallel processing, and NMR simulations that we'll talk briefly. Well, I have only 15 minutes, so I'm gonna try to give the main idea of what we've done this year, which is all of these publications. So I have to be quick and briefly. So I'll try to be do my best to try to give you the main idea of what we do. Right. To give you some context, what we do here, we work in the, as I mentioned before, several areas from image acquisition. We are developing a new microscope. We work on the data with artificial intelligence, for artificial intelligence tools in visualization. We also do statistical analysis to perform some simulations of rock properties, NMR simulations. And we hope with all this chain of work, we can improve results, aggregate some value to industry, and give new perspectives. To do so, we also have a team dedicated to work on multiple and parallel processing with GPUs. We develop our own hardware here to try to deal with that, our own solutions. Well, the first topics that I'm going to talk to you is the simulations. We use a random walk method to and we reconstruct a porous media with an X-ray tomography, and then we try to simulate it, the magnetization here, as you can see, and try to get the T2 distributions, right? So what we are interested in here is the nuclear magnetic relaxation has three main effects: the surface relaxation, the bulk relaxation, and diffusion relaxation. You are most interested in trying to modulate this magnetic field homogeneities in order to see if there's some bias in our analysis with the usual methods to get the T2 that in many cases ignores these homogeneities. So this is the theoretical model. What we are focused on modeling this to get the properties right. One of the interesting things that we already know is that the temperature does make a difference in the magnetization. As you can see, they have two temperatures here, 25 degrees and 75 degrees. and it does change the magnetization curve. This is something you already know from our simulations. Right? The second topic I'm gonna show you is our we have an effort to produce a software that works with deep learning. Uh, as I mentioned, has two teams working on that. This team work particularly with the microtomography and thin surfaces. So what we've done here is we develop a deep autoencoder, which is a deep learning architecture, and try to find hidden patterns in the micro CTs. What does this hidden pattern mean? For instance, it's an unsupervised learning method. We just feed the neural networks with the images, and they gives us a parameter space that represents some patterns. It might be hidden patterns in the data that we cannot see or we are not used to analyze and think about it, that can emerge. That's the interesting part of it. This is an example that we what we could produce. For instance, if you have two parameters, this might be related to the rock types. So there's different rock types, and it separates in using two parameters. But there's as I mentioned, the interesting part is that can be some hidden stuff in there. It's unsupervised, so we don't need classified data, which is also great. Um, so we also have in this implemented software automatic measurements of micro CT to do granulometry. And the good part of doing granulometry with digital rock physics is because it's a non-destructive in the sense that you keep the same sample. It's really fast, and it turns out that our results it, it, it seems to be we have a strong suggestion they are very precise compared to petrographic measurements. So this is also an interesting result we have. We can classify the rock types and make this automatic granulometry. If you have the right infrastructure, it will be very fast. Well, this is the part I'm more related with. The other deep learning team, we work on the other scale. We work with borehole images, like ultrasound and resistivity. And one of the things we proposed was a deep learning technique, a deep learning algorithm to estimate porosity and permeability, absolute porosity in this case, um, along the borehole. So what we do is we develop our own architecture. This time we use autoencoders, but as a supervised learning method, and we derive an estimation, a fair estimation of the permeability and porosity. Well, this result is already published. We have a partnership with Petrobras that gave us some data to analyze. And what is interesting is our methods use images only, these two kind of images. We have a very nice correlation with the real data, and even better with some traditional methods that use some logs and NMR or gamma rays, for instance. So we were very surprised because as a physicist, we don't know a lot about geology, and the geologists were very surprised. They say that this shouldn't be possible, but well, we did it. That's what we were very happy with that. Another after that, we also proposed another deep learning method to do something that geologists also said that shouldn't be possible. We proposed the deep learning architecture, this architecture that you're looking at here. These represent layers of neurons in the neural network. In this approach, use the same kinds of images, ultrasound and resistivity, to look for patterns and classify the lithology. So we've done that with, again, with the classified data from Petrobras, and we could find easily some of the rock types. The geologists answered to us that this was also impressive for them because they usually need more information than just these two kinds of images. So but we could find all of this was done in the pre-salt carbonates. It's worth saying the permeability, the porosity, and the the lithology prediction. So they're particularly difficult to see by eye, at least for me, it's difficult. But we could find in 94% of the times the diabasio, and also it's a great result with the folheiro, 82%. But even though these two other rock types wasn't that good, they were very surprisingly interesting results. Um, and it's worth saying that it's also very quick. So once you have the model trained, once you have all the machinery working, it can answer the whole borehole in a couple of minutes. So it's interesting for the geologists to have this, at least to correct this, to have a suggestion on what lithology they should use. So what's next on what we are doing? What we do is very data hungry in the deep learning part. So it's usually we require more classified data, which is not always available, unfortunately, to make the models even better. One thing that's an important topic in the deep learning community is the reliability. How good is our deep learning method? And more important, when it gets wrong, why it does get wrong. So an error estimation is something very important because sometimes, okay, deep learning gets it right most of the time, but when it gets wrong, sometimes it gets it really badly wrong. So one must know how it turns out to be a wrong result and how to quantify these error measurements. We have some work ongoing on this. We also are working on some multi-test deep learning, which is using high nonlinear deep learning architectures and neuron layers to get several parameters at the same time. So not only permeability and porosity, but what else we could find in the and hidden in the data. And the big question is what information is hidden on the data. We already use some available data that people do a lot of things with it, and we find a new roads on it. So what else can we do? What can extract for what's already there, right? For this, a widespread of unsupervised analysis, like the one I showed you before, is probably one of the answers because it can find the hidden patterns. Well, we need even more multiple parallel GPU, multi-parallelization of GPU, which is something very hard to achieve, but we have work ongoing on this part. And we hope that the NMR simulations could make a more detailed description of homogeneous medium and helps us to get what kind of biases we can have in our T2 distributions and send this result to describe a bigger samples. Well, that's what I have to tell you guys. Thank you very much.
Okay, thank you very much. I think we're a little tight on schedule too, so
Let
that's
me.
okay. So yeah, we've learned that also increased CO2 is a consequence of can be a consequence of increased oil recovery. And so we have Aline Dumaresque from Senai that is going to talk about the production of chemicals from CO2.
Good afternoon. Hello. Well, good afternoon, everyone. Thank you for the invitation, organizing committee. Today I'm going to talk about carbon dioxide capture and utilization. Just to start with, before going to the topic of my talk, I would like to introduce myself and also SENAI, the institute that I work for. So I am a PhD in genetics, and I work on synthetic biology. And for those that are not familiar with synthetic biology, in this discipline, we work with the genetics of organisms. Specifically, in the institute, I work with microorganisms. And the idea is that we can drive the carbon flux to chemicals of interest. So we use sugars or one carbon feedstocks by transformation inside the microorganism and drive it to chemicals. I work for SENAI, Innovation Institute of SENAI, that is a network of institutes from SENAI. We are 25 spread all over the country, working on different subjects. The one I work for is located here in Rio. Currently, we are located in the Riachuelo neighborhood, but next year we'll be moving to Fundão Island, so the same island where Federal University of Rio de Janeiro and also Petrobras and other companies are located. We have 5 technology platforms. One of them is synthetic biology and is the one that I am in charge of. What we can do for the company, so because we are SENAI, our goal is to support the increase in competitiveness of the companies. And to do that, we can help companies to develop their R&D strategy or their R&D projects, because we have laboratories, we have experts, we have PhD and master's researchers, and also matchmaking, because we have big capillarity in Brazil. We are spread all over the country, and we can help them to find suppliers, connect to companies, startups, and etc. And we have been working on CO2 and specifically one carbon feedstocks at the institutes, specifically in the platform that I'm in charge, that is the synthetic biology. Well, why we are looking at this? Because you all know the increase in CO2 emissions are dangerous for the environment, and there is a big awareness of the impacts of this in the world. So we have never seen an increase such as the one we are facing now. The last 50 years, the levels of carbon dioxide in the environment is really rising rapidly. Carbon dioxide is also the most important greenhouse gas among all the other gases. I have here a video just to show you how these emissions are impacting the temperature of the countries. So if you look at the red and orange circles, they are showing the increase in 1 degree or 2 degrees. Just for sake of curiosity, Brazil is here and Norway is here. And you can see as the years pass, the countries are getting temperatures higher. Orange and red, you can see 1 and 2 degrees above average. It's, I would say, somehow scary, isn't it? So we have to do something, and there is an urgent need to reduce emissions of greenhouse gases, specifically CO2. How can we reduce these emissions? We can do capture and storage. There's a technique that's already being used. But the problem of large-scale deployment is the economics. So we can also do something to use it. There's already some things being done with CO2. Some products, like the ones listed here, they are obtained directly from CO2. or you can do some kind of transformation to get other products. And you can do a chemical transformation or biological transformation. In the case of chemical conversion, we can see it's more common. You're gonna see that urea, salicylic acid, methanol, carbon nanotubes are already in the market. But specifically for biological conversion, we have still a field that it's in its infancy. It's starting, and now it's getting more opportunities and potential to be used for carbon utilization. So the idea is that we can get two benefits from CO2 reduction in emissions. We can get products, high value products, and also reduce the emissions, so reducing the impact in the environment. And a good strategy to do that is to target value-added products. We can do this using synthetic biology. So in this case, we use gas fermentation or enzymatic reactions to transform carbon dioxide into chemicals, or we can do chemical transformation using catalysts or electrocatalysts. In the institute I work for, we have these two platforms, and we are working on these two approaches. Just to give you a sip on what my colleagues that work on chemical transformation can do, I brought some examples. So using microfluidics to do amine scrubbing for CO2 capture, we have seen that using microfluidics can increase the mass transfer coefficient, and mass transfer is a problem when you consider using CO2, gas liquid transfer. And also when working on catalysis or electrocatalysis, they can determine thermodynamic and kinetic parameters and also develop some technical economical analysis. Talking about biochemical routes, so the idea of using microbes to transform the CO2 into chemicals. There are different options because naturally microbes can capture carbon dioxide or methane and in its metabolism transform it into chemicals. But they do not do the chemicals we want. So what we have to do is kind of drive the carbon to building blocks, and these building blocks will be used to get the chemicals that we want. The building blocks, I'm showing here some of them, mainly pyruvate and acetyl-CoA. These are key metabolites in the metabolism of microbes, and they can go easily in a few steps to different molecules. So we use this as a strategy to get versatile microbes, microbes that you can use to produce more than one chemical. For instance, from acetyl-CoA you can get these chemicals, and from pyruvate you can get this. So it's an interesting strategy to reduce the costs of development in the research. Just to give you an idea on these biochemical routes and biotransformation, I listed here the stage of development of the companies and some research institutes that are working on the transformation of one carbon feedstocks into chemicals. So what we can see in green is carbon dioxide, blue syngas and carbon monoxide, and in purple methane. It's important to point out here LanzaTech. Perhaps you have heard of this company. It has launched its commercial production facility this year, and it's planning to launch in the next year 3 other facilities. So it's working on syngas, planning to work also on carbon dioxide, and is also a great player in the market. Other two companies that we have to look at carefully, Calista and New Light Technologies, that are working on methane. Calista is currently producing single-cell protein from methane, and New Light Technologies is working on biopolymers, PHAs. I didn't mention LanzaTech is currently producing ethanol from syngas. And there are different other companies working. One important thing to mention is that carbon dioxide, there is no commercial production plant yet being that was found in our search. This is a great opportunity, but obviously there are many challenges, and I brought here some of that just very quickly to show you. This is a bioreactor. That's a reactor where the bio transformation occurs. You have to feed it with the feedstock, carbon dioxide, methane, CO. You have to use a microorganism. You have to set bioprocess conditions and reactor design, and then you have to do the downstream. In each of these steps, you have some challenges. For instance, feedstock, because we work with living organisms, you have to be aware that some contaminants in the stream may kill your microorganisms, so we have to be aware of that. Synthetic biology, because we have to engineer the microorganism, and there is not genetic tools for all the microorganisms, mainly when we consider methanotrophs. Bioprocess conditions and reactor design. So the low solubility of the gases is the main drawback. So the mass transfer from gas to liquid is a big challenge. We have to work on the reactor design. And specifically for carbon dioxide, we have to be aware that it is a very oxidized molecule, and the energy input to reduce this to other chemicals can be a bottleneck. There are different ways to provide electrons, as I listed here, but this is something that has to be developed together with the microorganisms, because it can be expensive providing electrons. This is just an example of reactor design to increase mass transfer from LanzaTech to Loops and Calista. There are many challenges, but we believe the future is bright for CO2, because there are other commercial facilities planned, as I mentioned before, LanzaTech, different facilities in partnership with different companies. There is a growing research landscape worldwide. So if you look at orange are the papers and blue patents. So from the years 2000, it has grown a lot. So there are a lot of things in the academia. Companies should look at that. They are now working on new technologies, so there are plenty of opportunities. And carbon taxation is something that in the future may drive the companies to invest more. There are already countries that have carbon taxation, not all of them, but this is something that may change the landscape. Thank you for the attention. We are open for collaboration in case you want. We have some works on carbon dioxide, but also in the other platforms, and I'm available if you want to know more.
Okay, thank you. Are there any questions? about that? Guess not. So thank you very much. What we're going to do now, we have 10 more minutes before the plenary session here, and what we're supposed to do, and now we need some help from everyone. Floor is open to everyone to comment on what we have presented, the different speakers have presented, and what are some common denominators, what can we collaborate on, do the different IOR solutions that we're working for in Brazil and Norway? Do we see similarities? Too much differences to collaborate? Is the environmental aspects of interest in both places? Comments to that? Would anyone like to start on that? Perhaps I could challenge Paolo to comment something on what do you see from what you presented. You gave the overview here in Brazil of methods. How does it compare to Norway?
Well, I'm not much aware of the methods you're using in Norway, but the focus now on the development of new fields in Brazil are mainly in the pre-salt. And for the pre-salt, the main focus is using the CO2 for EOR processes. They are Petrobras is doing WAG in Lula field because they don't have yet gas pipelines to export the gas production, which is very high. Lula field produces 220 barrels of gas for each barrel of oil, and 40% of that is CO2. So the most logic option for them was to do WAG using a rich CO2 flow of natural gas reinjected in the reservoir. But the future idea is to separate the CO2, export the natural gas, and reinject only the CO2 using WAG with low salinity water, with carbonated water, and together with other techniques, maybe CO2 foams, biopolymers, and things like that. And moving a little bit further regarding collaboration to develop all these techniques in Brazil and in Norway, I think we are in the right time to establish this collaboration because the Brazilian Petroleum Agency has a new administration. And talking to Alfredo Renault, he was here in the opening yesterday, I feel that the Brazilian Petroleum Agency is very open to new ideas for funding and collaboration. So this is the right time to discuss with the Petroleum Agency new ideas for collaboration. For example, next year, the Petroleum Agency will bring back the idea of the Human Resources Program, where they're going to fund masters and PhD and postdocs in Brazil. So why not propose them also to fund masters, postdocs, and PhD outside Brazil, maybe in Norway, in Norwegian universities, and we have done this in the past in this project with Shell. At that time, it was BG, and we had the authorization of the Petroleum Agency to send some PhD students to Hedetwatt and Enebra to do their full PhD and sandwich PhD. So why not reproducing the same model now in collaboration with other institutes? I think the time is right to propose this to the Petroleum Agency. So with the support of the Norwegian institutions and companies, I believe we can do that. So probably there's at least one Norwegian company operating in Brazil that would be very interested in do that. Okay.
Thank you, Paolo. And Riske?
Yeah, just a very short question regarding that. Would that be used for the tax levy funds? Yes. My understanding from our discussions with Shell is that AFP doesn't allow that. They allowed in the past, in 2014, when we proposed that, because we were paying Brazilian students to study abroad, And after that, they will come back to Brazil to bring back this experience. So once this whole process was managed by the Brazilian Research Council, CNPq. So the student, when he goes abroad for the PhD, for example, it signs an agreement with CNPq stating that he has to spend back in Brazil the same amount of time he spent outside transferring technology back to Brazil. So I believe that the Petroleum Agency is very open to this idea now. If we propose them, I think we have the great chance to being successful. What the Petroleum Agency does not allow is to do the full research outside Brazil. This is not allowed by law. But paying students to go abroad to do a PhD and then bring back, transfer knowledge to the Brazilian market, I think they will see this with good eyes. No, but the agreement we have with CNPq that it's still valid, allow us to send a full PhD outside and sandwich PhD for 2 years in a co-tutel agreement. Yeah, this is an agreement back in that was signed back in 2014. Since then, things have changed a little bit, but we can change it back. And I think that the time is now.
Okay, yeah.
I would like to sort of look ahead a little bit perspective on the collaboration between Norway and Brazil. A lot of things have been said by Paulo, but I think one of the main challenges for the E&P industry is looking ahead, the low emission oil and gas production for the combat of the climate changes. In Norway, it was announced yesterday, not announced, but said yesterday that Norway is creating a new center for low emission oil and gas is coming. So next year the center will be up running. Either Norse or Sintef, there's two competitors, but we also work together to work on CO2 capture and storage. The good thing is that North Sea is a huge, how should I say, graveyard or place for large amount of CO2 storage, long-term geological storage for the whole European CO2 even, because we have North Sea with a lot of good reservoirs, aquifers to store in the parallel with the matured oil and gas industry. So it's a perfect match, in my opinion. At the same time, North Sea is sort of suffering on CO2 EOR, because if you do the EOR, you need a lot of CO2, not just a little CO2 from here and there. You need millions and tons of CO2. And it has to come steady in a short period. At the same time, it's not going forever. So if you have a CO2 capture from a power plant, it comes forever. I mean, maybe 50 years, but you just, for the CO2 EOR, you only need maybe 5 years for a particular field. So it's a mismatch between supply and usage. The beauty of Brazil is that you have actually CO2 in your reservoirs. It's sort of a God-given present, yeah, for this. And
it's fantastic for logistics.
Exactly. And it's very good that you are ahead of us in North Sea on CO2 EOR, demonstrating the benefit and efficiency of CO2 EOR. So I think we have a lot of areas to collaborate and also encourage maybe the agencies, RNC and FINEP and whatever, maybe open up for the CO2 EOR collaboration. In Norway, we have this CLIMIT. Maybe CLIMIT can be also part of this co-fund program in the future.
Questions, comments?
I'm an outsider in this session, so I'm sort of asking a naive question. Recently, about a few weeks ago, the European auditing system has evaluated the impact of more than a decade of research into carbon sequestration and storage. Their conclusion was that there's no measurable improvement in that result, in that regard. I mean, I had the report here. So I was wondering, I mean, you are the specialists here. Is this actually a promising and successful avenue, CCS, to capture CO2? I mean, the quote from this European Court of Auditors is demonstrating carbon capture and storage and innovative renewables at commercial scale in the EU intended progress not achieved in the past decade. Maybe, I mean, I'm sure that some of you can answer this better than me. I'm just so, but I think it's useful to hear your comments.
I don't know if it's better.
Comments on that?
Yeah.
Norse and myself, I represent this actually a couple of Norwegian institutes in the European Research Alliance for CCS. So we, in collaboration, we work with the European Research Institutes and universities. There are a lot of progress, I would say, both in the capture and storage. The technology is maturing. The cost per ton of CO2 is reducing. And actually there are some successful demonstration, large-scale demonstration projects in US. And you know, in US, they don't do things for fun. They do things for business. So if they can manage, I think the rest of the world can be following, you know. So I really personally believe that if the policy is right, you know, the CCS will be successful. The question is how fast we can implement, because the time is very limited now. In the next 10 years, probably, we should have a large-scale CCS really to significantly reduce the CO2 emitted to the air. That means probably maybe every week we should create a plant, right, with a million scale to capture the CO2 and then put them underground. So in that perspective, I'm pessimistic. I think the time is running from us, unfortunately.
Okay. To left, quick one.
Quickie. Sales gas is max 3% CO2. And you said you have 40% CO2 in your produced gas. You could use membranes and reintroduce it as CO2 into the reservoirs for enhanced oil recovery. But you could use membranes, not this amine, because that is a chemical. It's not sustainable. You have to watch that sustainability. Adding chemicals, why do that when you have the membranes? And back to my presentation on smart water in your reservoir. Obviously, if it has barium, you should not use sulfate reduction because it's not compatible. So there are drawbacks also. But membranes and CO2 removal has been established for a long time, also by Equinor.
But it's all the price, you know. If you do the membrane for the size of the volume, you need probably kilometers long of membranes. I mean, it's a big scale. That's why the economy is so important.
I have not talked about the scale.
No, but we have to talk about that.
Yeah.
Lula, how much gas you have.
We have.
If you use a membrane, it will be very expensive. That's probably.
You know that, or you estimate, or you assume, you guess.
I've heard people say membrane is great, but if you put all the membranes for Lula, probably need a new platform.
Yeah. Injection rate in Lula is 1:1.
Yeah.
The producer well is producing 33 barrels a day of oil.
Right.
So it means they're injecting 33 barrels of water.
Yeah, so you could maybe replace part of that with CO2. Yeah. That was sort of my point.
Okay, thank you. Seems like we're getting some interesting discussions going now, but I'm afraid that our time's up for now. It'll have to be in the 7th conference, I guess, November conference. But it just remains for me to say thank you to all the speakers and to those of you who attended, and see you again next time.
Thank you very much.
copy den opp. Ok, det må bare huske å... Hva? Ja, det kan starte faktisk. Jeg skal begynne. Jeg skal begynne å der. Okay, thank you for coming back. I think we've got the survivors of the conference. Thank you for your attention and endurance. What we'll do now is have a quick summary of what has happened and then thank some very important people who've been involved in the conference. So what I'll ask is each session chairman for today to give a short summary of what's happening. And first up is Harold from Digitalisation. Well, you can go.
Yep, thank you. It works. Well, we had a very nice and interesting session on digitalization and automation workshop, DNA. And yeah, there we are. We had five speakers. Nice topic. Organizational and human aspects of digitalization in oil and gas. Eric Monteiro, the second to the left. Building ontologies for the petroleum domain by Mara Abel from Federal University Rio Grande do Sul. She's in the middle. And status of ontology-based data access in exploration by Adnan Latif, the University of Oslo. The second from right. And then finally, the new digital transformation in downstream oil and gas industry, a case study by José Ricardo from Federal University of Bahia to the right there. I just noticed some policy takeaways, I think, because I'm not going to dive into some of these topics. But first of all, digitalization is on every lips, and that goes in industry. Every company, suppliers and oil companies, have their wish and desire to do something in digitalization. And they claim this is a new way to reduce costs and improve efficiency. But it's a lot of misconceptions and misunderstandings and knowledge need out there in order to clean up what really can do with this. New business models and human aspects, including also cooperation across silos. The new business models, all companies that I have met, actually, oil company suppliers, point to that demand, that need actually to reconsider what this DNA can offer related to how to organize people. And Erik talked about that and brought it a little bit further than what I have mentioned here. Bringing data to decision, the exponential flow of data, huge amount of data coming in. And all companies say that we have to do something with this data. We do it from the academics too. To capture the economic value, data has no value unless you use it in decisions. So it has to be transferred over to decisions for capturing the economic value. And then we had two nice and very interesting overview of the need for systematic ontology or ontology approach, a complicated issue. It has been there for some years, but we have two very nice and very good presentations, and I advise you to go back and have a look into these two presentations. Then maybe I'd take this Eduardo approach and just say that data-driven versus model-driven approaches. That is some sort of also an issue in the debate. It can be combinations, and it is often the short-term versus the long-term aspects that counts. And then finally, we discussed also the opportunities for cooperation between Brazil and Norway. DNA, digitalization and automation is a very good case for use cases and synergies in academia and industry. And I hope and believe that we are going to do something with this. And we have a strong interest in Norway at different places, including NTNU, where I work, and also in Brazil. Altogether, we had a very nice approach. I like the panel. We tried to get the response from the audience. That's something we should consider for next, to have time and how to get the dialogues going. Thank you.
Thank you, Harold. Okay. I think we'll go through in chronological order. So next up is subsea field development. Sigbjørn, you got something to...
The Word document. I'll roll it through for you. Yes. Yeah. Okay, good.
Yes, I'm. Is the green light on? Hello, can you hear me? Hello. Yes. Yes. Okay. Yes, I'm Sigbjørn Sangesland, and I was the chair of the subsea field development session. And we had 6-7 presentations, and we start with subsea developments perspective in Brazil by Casio Cupil, and he had a brief review of subsea technology and installation technique presented, introduction of future production system trends and scenarios, importance of improved recovery for mature field, low carbon and digital transformation, low operation cost would be key factors in the near future developments. And importance of disruptive innovation of the technology and introducing of subsea technology drivers. I think that was the main point. Then we had the same heading, subsea development perspective in Norway, and talk about subsea technology in Equinor Brazil. He mentioned subsea water treatment, C-box for treatment of water to be injected. Introduced development of membrane and for salt and sulfide removal, and needs for subsea power distribution developments, and also subsea all-electric monitoring and battery is a specific issue. Then we had a presentation by NTNU, optimizing subsea production facility layout to minimize risk and cost. And this was about balancing cost and risk in petroleum field development, described a subsea business model, and the reduction of overall cost, subsea cost, by reducing, for example, wellbore length, technical risk and cost. For instance, satellite versus template well. Satellite wells involve shorter drilling length and significant potential for saving cost. Then there was a presentation by Unicamp, ongoing research topic on wellbore intervention, drilling and production. And he talked about project ongoing at Unicamp, present some specific research result on drills or drill ship movement with BOP suspended in operation, and also problem with wellhead fatigue and influence of wellbore temperature. And then there was a presentation of a new concept for element heat compensating. That is a new floater concept with low or very low heave compensating or heave motion. And the motion in heave is reduced by providing an air cushion device. Hydrostatic displacement with air cushion done by a master student. A floater would be indicated for light and middle weight wellbore intervention, and also for production is potential application. And hydrodynamic motion analysis is being conducted by a doctoral student in a joint work with Brazil. Then there was a presentation by Unicamp on applying advanced process control to subsea environment. He talked about advanced process control for subsea environmental and control to predict the surge in subsea compressor and how to treat uncertainties in the prediction of process was also mentioned. Also, case study was presented. Then there was a presentation, marine operation, by Pierre Major and NTNU in Ålesund. It's a startup company with participation from NTNU and companies such as Rolls-Royce, among others, located in Ålesund, and with also an office in Brazil. Training programs developed for offshore operation in order to avoid human errors in operation. And then myself, I presented subsea production and separation is an SFI, SUBPRO, Center for Research-Based Innovation within subsea production and processing. And there is from 2015 to 2023, we plan to educate 40 PhD and postdoc students. And then I mentioned the Brazilian Norwegian in Parte Subsea Operation Consortium project, 3 years from 2017 to 2019. And here we run annual workshop in Brazil and Norway. We exchange students. So far, 9 students have been exchanged. The goal is to develop joint proposal and also joint course and supervision of PhD candidate and master student. That is probably the last. Yes, that's all.
Thank you. Okay, next up is Starnasani. Yeah.
Is this on? Yeah. Okay. Well, we just finished, so I'll just have to take it directly here with no slides. But I'll try, and please supplement if I forget something. Well, yeah, our session was on environment and EOR. And we've had that earlier too. It's both environmental and EOR issues, but we're trying to see those two disciplines in connections. And first of all, we had now at this session an overview from Brazil. What are the important EOR issues here? And also from Norway, the IOR Center of Norway. What are the current EOR issues that we're working on? And it was mentioned from Brazil that there is a lack of historic models for the EOR in Brazil, which is a problem. But nevertheless, it's clear, it seems very clear that the EOR time is now, because, and it's also pinpointed by ANP that it's faster EMP in Brazil is needed, and there's a huge potential for better revenue. For example, a field, Libra field was mentioned with 5.3 billions of dollars increase in potential revenue with EOR solutions. On the Norwegian side, it was mentioned that 7% more oil can be recovered by EOR methods. Then we had a couple of talks from the Norwegian IOR Center, and we deliberately chose those for this session because we have the environment and EOR focus. EOR solutions that do have environmental implications that are positive. Not all have that, but these definitely have. It was about smart water, where there are no added chemicals, but the change of the seawater constituents that works. So, and we had some presentation of chemical EOR versus non-chemical EOR methods. Wettability is very important there. And then we had from IFE about a green shift in tracer technology used in EOR, where you go from barrels of chemicals being used down to bottles. So this is a green shift in the way that these tracer chemicals are developed for the EOR solutions. Then we had some examples and talks about multidisciplinary transfer and use of methods from physics, from this building, over to geology and environmental methods to assess the environmental risks of EOR methods, for example. Then we had a presentation from Brazil about biotechnological CO2 capture and utilization. That is also an important EOR issue, CO2. And yeah, there's a lot of information there, but the take-home message was that the future is bright for CO2 utilization these days. And then we had, in the summary, we had a number of points. And again, that the EOR collaboration might be a very right time for that, that the Brazilian Petrology Agency has signaled interest in that, and that interesting stimulation for that purpose could be master, PhD student, and postdocs. So funding for that to reinitiate some of that could be a good means to get this collaboration going. And then, yeah, we didn't have a panel discussion, but we actually in the last 10 minutes really had some discussion and some attempts for discussion. And topics were, again, that we can't separate EOR and environment aspects anymore. And also that we should look ahead and look into low emission, and we are establishing a low emission center in Norway now. It was also mentioned carbon capture, and maybe, yeah, and it was raised the question, is CCS, carbon capture storage, is it feasible? We didn't get to the end of that discussion, but at least the discussion was, the topic was raised. Also, again, about chemical and non-chemical EOR. What is the best way forward? And maybe that also point for further collaboration could be CO2 EOR collaboration between Norway and Brazil. Thank you.
And then last up is Andrea on the flow assurance session.
Hello, my name is Andrea Schmöli. I'm working at SINTEF, and I was coordinating the flow assurance session. It was a really interesting session, and we have a nice constellation of industry and also academia and research institutions. We had the oil company Petrobras presented about the challenges about producing with multi-phase flows with high CO2 content. And that's really interesting because it was challenging the classical multi-phase flow problems and the multi-phase flow predictive tools by using including the CO2 in the picture. Afterwards, we start to get a little bit more modern, and we had a talk about from Kongsberg Digital, and that was how can we couple predictive modeling and physical modeling with data analytics and machine learning. And it was really interesting because one of the conclusions was that it's not possible 100% of working with data models. We really need to have predictive models in place, especially to determining determining rare events. Afterwards, we had a Brazilian company, ESSS, that together with ISDB Flowtech, that were presenting their work on hydrates, and especially determining or developing better hydrate models for having a better hydrate management strategy. We had a coffee break, and then we start with academia and research institutions. We start with the University of Oslo, where Anis presented his work on stratified flow. It was really interesting because even though we can think that stratified flow is the simplest flow pattern, it's so complex that we still cannot understand it. And we need to implement quite a lot of this understanding in the models because we need predictive models. Afterwards, we continue with the PUC, and Professor Luis Fernando Acevedo presented state of the art on the work for wax deposition, both modeling and experiments. And last but not least, and a little bit longer than we should have, it was a presentation from myself, from SINTEF, together with ISDB, where we presented the research and joint research and development efforts that we are working with regarding flow assurance. And this was mainly, especially for brownfields and greenfields applications, both applicable for Norway and Brazil. Thank you.
Okay, all that's lasts between now and us going home is that I would very much like to thank a very large group of people involved in this conference. I had the role of technical chairman and project manager for this conference, and it was a spectacularly easy job because of the effort made by the various session chairs at the session. And so I'd like to thank very much all the session chairs for the work that has been done, and I think everyone agrees that each of the sessions has been a very successful forum. I'd like someone also to try to get Rune Andersen back into the room. I saw that he disappeared with William Christensen, who I also wanted to thank. William's about to disappear. Okay, William's gone. Thank you, William. So we wish also to very much thank the Ministry for Petroleum and Energy in Norway for financing the project and ensuring that this conference will be continuing for the next 2 years. So we hope that you see you all back here now. And now I would really, really want to give a thanks to a man who has been a magnificent support for me and a role model in seeing how you actually communicate with people and build networks, and has been a person who's been very easy to work with and has done a magnificent job in organising this conference. And I understand that it will be the last time that Rune will be in Rio de Janeiro as the November conference person as technical attaché, because your term's ending. So I think I would really want to give a round of applause, perhaps even a standing round of applause, to Rune for his... And Rune is assisted by a very large group of very, very talented people, including a lady called Pilar, who is standing over there, who has organised everything spectacularly well. Thank you.
Without them, the world wouldn't go around, you know. So I have to depend on them and also for Marcio here, a very good colleague, friend, and cooperating partner that is kind of developed this conference as well and giving it as our house. And thank you, Maestro. And I've been here for all the 6 conferences, and I think my pleasure is to see how this conference has developed and how the relations between institutions has developed and how Norway and Brazilians work together have been stronger and deeper and tighter every year. So I'm not afraid of next year. It will just go on, I think. And also our funding partner, that's why I came in a little bit late, because the ministry he left, he had to go to the airport. So I'm very thankful for that we can build some strategy for the future, at least for the 2 next time. Makes it easier to plan, because from before it has been from year to year. So thank you very much for being here and to contributing to the excellence conference, the best conference ever. Maybe we will ask you next time. We will ask you how you pursue the conference. David will see to that.
We'll be sending out a questionnaire in the next couple of days about the conference, about how you've enjoyed it, what things you can think we can improve, and what input we would like to have in the 2019 conference. So please give us more than 20% response on that. Great, thank you. Bye-bye. Ja, det.